All right, hi everyone. This is our presentation on RAMP and the Red Hat experience. I'm Sarah Egan. I'm a civil engineer.
My name is Nathan Hunsaray, computer engineering major.
I'm Julia Meesmer. I'm a biomedical engineering major.
My name is Victoria Wynn, and I'm a high school senior.
All right, and this is our project called the Study Buddy.
Staying motivated to study is difficult to begin with, but during a global pandemic, it can be especially challenging. Our project, the Study Buddy Study Tracker, aims to make the responsibility more manageable and enjoyable for students by, allowing them to compare with their friends and classmates, and also, breaking down the work that they have to do using the Pomodoro Technique.
The Pomodoro Technique is a method of studying that involves a constant period of study for about 20 to 30 minutes, followed by a short 5-minute break. And this just ensures maximum efficiency and focus during your study time.
Now you have our flowchart detailing how our project works in detail. Now, like most of the projects you see today, our main engineering work involves the TI breadboard. So the first thing you're obviously going to want to do is plug it in and have a stable Wi-Fi connection so you can use it effectively. When you first start it, we programmed a little jingle so that you know it's all set up.
From there, you're going to select the type of studying you're going to be doing. You have 3 options here, group work, homework, and test prep using the joystick. You can either push the joystick upwards along the y-axis or left or right along the x-axis to select either of the options while holding down button 1.
And doing this, it will record this data point and send it to your own personal Adafruit feed, which is then connected to our team dashboard. And at the same time, we have a bot set up so that every time your Adafruit feed receives this piece of data, it'll send a message to our team Discord channel. Just that way we can get a little reminder to check out the dashboard every time it updates with our study sessions.
Now, concurrently with this Wi-Fi interactivity, it also begins a timer that starts to count how long our user has been studying for. Now, this data starts off in seconds, but then we do math on it to convert it to minutes and consequently hours if the session lasts long enough.
So it'll first start with a timer that runs 20 minutes, and then after that 20 minutes, a buzzer will sound indicating that your study time is over. As it buzzes, it'll say, oh, it's break time. So you'll press button 1 to turn off the buzz, and then it'll set the next timer for the study time until that finishes, and then you'll press button 1 again to turn off the buzzer to start the next study timer. In between, if you would like to take a break, besides the break times, you press down on the joystick button to pause the timer, and then to unpause it, you just press it down again.
All right, so now this cycle continues on for as long as the user decides to study for, but whenever they get tired or their session ends, all they have to do is press button 2 until they hear a jingle, and their data automatically gets sent to Adafruit for publishing on the dashboard.
And moving on to our methods and results for this project.
So we actually divided our coding into 3 main compartments that were then combined near the end of our project's design. We started off with the study timer, we moved on to the joystick selection interface, and ended off with the Wi-Fi connectivity. Now, the study timer pretty much worked by increasing a variable by 1 each time a delay of 1,000 milliseconds was passed. Now, like I said earlier, this data was then divided as needed, so it would be available in terms of minutes or hours. Now, we also had a buzzer that would go off every 20 minutes and consequently every 10 minutes, with it repeating this interval until the person or the user has decided to finish studying. Now, after we were done with this, we moved on to the joystick selection interface. Now, this one was made possible using a variable that changes value based on what joystick threshold was passed, based on whether they flicked it left, right, or up, corresponding to the 3 different study methods we have available.
And lastly, our component regarding the Wi-Fi connectivity. This utilized the Wi-Fi booster pack that came with the TI Launchpad. And using this, we were able to send this data to show our trends that were posted on our shared Adafruit dashboard, which you can see here. So every time you flick the joystick, this section right here will update with the group member's last activity. And at the end of the study session, it'll post the length of your session here on this graph. So that way you can see it update in real time and you can kind of compete against your friends to see who has the strongest studying skills of the day. And if you would like, you can check out this dashboard as it updates in real time by scanning the QR code here down in the lower corner.
Throughout our time with Red Hat over the course of 6 weeks, we talked about several different topics. Our first week, we started off with skills for effective multidisciplinary teams. And kind of a all-encompassing phrase there is a shared mission is the fuel of a project. And to make this shared mission go as smoothly as possible, we have to remember the good habits for effective teamwork. We have strategy, and strategy is the creation of a plan of action, per se, like steps that you want to take towards the goal that you want to achieve. And this is generally not a finalized idea. Then it's a lot of brainstorming initially. Next, we have design, and design is an organized visual representation of the strategy that you previously came up with. This can be used with computer modeling, SolidWorks, CAD. It can also be written instructions. We'll get to that later on in documentation. Or it can be even a presentation, sort of like what we're doing now, because we're showing our project design. And then the next one is engineering, and engineering is acting on the strategy that you created and using the design that you came up with to manifest the product that you're looking to create as the end goal. Validation is like testing, trial and error. So you're going to test your creation, you're going to find out what goes right and what goes wrong, and you're going to keep going until you have something that works closely to what you're hoping to get. And documentation is very important because it records all of the previous steps so that those who look at your project can understand what you did, what you went through, and it can also deter a lot of confusion within the team itself as well, because if each member documents what they do and then everyone shares it, then lots of things it will be more efficient essentially, because you won't have to try to figure out what other people are doing. Management is related to the organization of a team, because if you don't have one person or several people essentially giving out jobs for the team, like tasks to do, it can get confusing and a lot of things might not get done, or too many things might get done, and you may not finish the project to your maximum efficiency. And then support is, when you don't know the answer to something, you don't know how to do something, you can go to your teammate and you can ask them if they know, and if they don't know, then you can work together to find a solution, or you can ask someone else who might know.
So there's also the 4 C's of team interactions. To start off, there's collaborate, which means to work together. So collaborating within a team is important because you cannot just go off and do your own things. It's teamwork. You have to come together and know what your goal is and work towards that goal. To compete, it will be competing your ideas against one another's, but it's within the realm of trying to look for innovative designs constantly. And then to cooperate, even though you might be doing your own tasks, you can still help each other by cooperating with each other when doing all these problems that you may have. And with conflict, you may have differing ideas or you may not agree with one another, but it helps create those more um, imaginative designs that can create an even better solution. So with that, inclusive teams yield better, more innovative designs.
And during week 2, we talked about the design thinking process, which is a cyclic and iterative cycle that puts the focus on understanding your user when it comes to creating solutions or products to solve problems. So this begins with understanding, which involves empathizing with your user, often done through research in order to collect data on the users. Then you can go on to define the specific problem that truly needs to be solved, just so that way you can really appeal to the needs of those that you're trying to help. Next comes the fun part and exploration. Here you get to use the process of ideation where you can think of the craziest, most creative ways that you could solve a problem. This way you can yield, hopefully, the most innovative solution. And from there, after deciding upon your ideas, you can build a prototype. And in doing so, this gives you a tangible representation of your possible end product. And using that, you can follow up with your users and run some tests with them and see how they react to it, if they have any feedback. So if you need to make any corrections, you can always go back in the process and redesign. And once you finally have reached a satisfactory point in your design, you can implement the product and put it into effect. And from there, it's always important to follow up and collect new data, just so that way, as people evolve, your products can evolve too.
Another thing that we talked about in fairly great detail is how to properly give and receive feedback. Now, I'm going to focus on the giving feedback portion, starting with what you should do while giving this feedback. Now, think about what feedback is supposed to be. It's not supposed to be chastising or overly praising. It's supposed to be a method of reinforcing good behavior or encouraging it. Now, making feedback personal or attacking who you're giving this feedback to only closes them off from improving as a person. So you're definitely going to want to avoid making personal attacks on on whoever you're giving feedback to. Now, we also had different ways of qualifying types of feedback. We had it based on what type of work was done to require feedback. That's negative feedback for work that needs improvement, and positive feedback for encouragement on already good work. Now, we also have it based on how helpful said feedback was. We have constructive feedback and unconstructive feedback, which are helpful and unhelpful, respectively.
It's also important when receiving feedback to have good habits as well. So you want to take it in stride, such as being appreciative of what they tell you because they took the time to collect their thoughts and make an opinion about whatever you're working on. And it's good to know that they took that time, and it's great to say thank you. You want to have good active listening skills. Sometimes when they give their feedback, it might be a little repetitive because they might be stuck on something about your project. So you want to filter out those so that way you can pick up other parts of the feedback in case there's more, because there's always more to it besides one. You can ask for clarifications because if you don't understand what they're trying to tell you, it's hard to fix what they want you to try and fix. Then it's great to follow up as well. If you don't have any questions at the moment, you can always send an email saying, I'm sorry, could you maybe clarify what you said that day? I wasn't understanding most of it.
This was one of our especially fun meetings, at least for me. We talked a lot about technical interview skills, and we even did mock interviews where a few of us volunteered to be interviewed by Red Hat mentors. They asked us each 2 questions. Usually kind of generalized questions about successes and failures, and not anything super technical because not all of us were going into software development. But we answered the questions, and then we received feedback from both our peers and the mentors that were present, which was really helpful. And then after that, the mentors opened up the floor for discussion and questions regarding the technical interview reading they had shared, which had been a PowerPoint, very extensive PowerPoint, very informative. And we discussed that for a little while, and we all got the chance to ask any questions we had about resumes, resume building, what it looks like from their end when they're hiring somebody, LinkedIn, any questions we had really about just job search and technical interview and things related to that. They were very helpful with answering questions very thoroughly as well.
And some, excuse me, some of the biggest ideas that we took away from this session during an interview, some things that you should do are to take notes or to restate a question in order to effectively answer it, especially when it comes to like two-part questions. Also, whenever asked, you should discuss scenarios where you've been successful, even if you've been sharing an experience with a failure, just so that way you can always show your interviewer that you've come out on top. And as well, you should speak with passion and clarity in order to really engage your interviewer. Some other things to remember are to show interest or involvement in your employer's company, including keywords in your resume that are relevant to the job description that you're applying for, as well as presenting any portfolio work to show off any other skills that you've practiced. And lastly, following up with a personalized thank you specific to the interviewer, just so that way they know that you're appreciative of the experience, and hopefully that will help you get your job in the future.
Another thing that we went over a good amount in our meetings is systems engineering, which I personally believe is important for every engineering major, not just computer. And we went over mainly two main types of software design cycles or pathways: agile and waterfall. Now, the main difference between these two is that agile is more of a cyclic pattern, which makes it more reactive because it's more general. Now, waterfall is more of a straightforward process, being personalized to a specific plan instead of reacting to changes to the consumer environment as effectively. Now, there are certain skills that are important to have that any systems engineer should have. Now, these three that I think are the most important would be how to receive feedback and how to put this feedback back into your work in order to utilize it properly. Now, you should also be able to receive input from both internally within your team as well as externally from users via your prototypes.
And lastly, just to close up our presentation, we wanted to talk about some of our reflections that we had on the program as a whole. So when it comes to our meetings with the Red Hat team, we really wanted to emphasize the support that they gave us and be really thankful for all the wisdom that they shared.
During the talk about the meetings, I found it especially helpful to remember to just take a breath and slow down instead of filling your speech with bridges like or as or as in, because it really helps with the flow of what you're really saying.
I believe that Red Hat was an excellent experience for all of us. We got to really kind of learn a little bit about networking, and we gained a lot of knowledge from them. They got to share their experiences and the things that they'd learned about working in the industry, which was awesome. And that was really helpful, and it felt very supported by them. And it was really helpful to talk about how to conquer problem solving and project design, because that's not always something you learn about in high school.
Then we also have the importance of working together as a team. If honestly, if we didn't work as a team, I don't know if we would have had our study buzzer. But we did, and we were able to complete our project, and that's what we have, an amazing study buzzer. And each one of us worked together collaboratively, and we worked effectively. So it all came together, and that's how our study buzzer is our greatest project.
I think in terms of improving ramp, we all have a general consensus that it would be really nice to see more engineering pathways represented and to see how they really relate with each other. I think we all agree with that, yeah?
Mhm. And even so, I think the program as a whole, we can all agree that it was just a really amazing experience, and we're really grateful for all of the opportunities that have been opened up to us from both the faculty and our industry mentors.
Absolutely fantastic.
Of course, would do it again.
I second that.
Hearded.
All right.
All right. That's it. We're done.
I'm gonna turn off the recording.